Howdy, IB. It's Miss Kosh. There were some questions on some of the book problems, so let me talk through this. First of all, we have a three-digit number is made up using the digits 0 through 7, but you can only use one each. So if there's no restrictions, well, it says, and the number cannot start with 0. So that means of the 8 choices, we have 7 options for the first spot. Okay, but we still had 8 numbers. We've used one of them. We know it wasn't a 0, but now we have 7 options for the second choice. Okay, because of the 8, we picked one already. One was already used, and then there's 7 left for the second number, the second digit. And then now there's 6 left for the third digit, and that is how we get 294 when you multiply those together. So notice how I use those little dashes to indicate what digit we were talking about. Looking at B, the number must end in a 2, 4, or 6. So what I did is I started with that third digit, and I said, okay, there's only 3 choices. I don't know. We have 3 choices for that first one. And now then I went back to the first digit of that number, keeping in mind we can't use a 0 there, and now we've already picked a number to go into the third spot. So then there's 6 choices here. Well, of the 8 digits, we've used 2 already, which leaves us 6 for that last spot right there. And those multiply and give me 108. So next on C, it says the number must end in 0. So we only have one option for what our last digit should be. It was a 0. So then there are 7 options for the first digit and 6 options for the second digit, and that gives us 42. Okay, part D was the one where someone had a question, and the problem said the number must be even. So what I did is I considered this in, we have the restriction that the first digit can't be 0. So I need to consider that, but if I ended with a 0, that would be an even number. So what I did is I said, okay, let's say that the last digit is 0. Well, there's one way that could happen, and then it's 7 times 6. And this is that scenario from part C, right? Then I said, okay, well, what happens if the last digit is not 0? Well, that means it could be an even number if it ended in a 2, a 4, or a 6. Actually, what this is really doing is it's putting these two things together. I'm just now noticing that. I worked through the problem, didn't catch that, but that's what they were doing. So this, once again, is, well, it's the same. It's part B. But we could have one of those two things happening. One of those two things happen, and so therefore, we're going to add them together. So either one of these gives you that odd, I lied. Either one of those scenarios gives you an even number, and so we have to add them together, and that's how we get that 150. Then there was a question on number 19, and it tells us that Alice had booked 10 adjacent front row seats, which is a little more information. I guess we care that they're adjacent. We don't care that they're front row, for a basketball game for herself and 9 friends. Okay, how many different arrangements are possible? Well, you could use this little setup that I already have down here. You've got 10 choices for the first one, and 9, 8, 7, you can keep going. What that ends up being is that's a factorial. That's 10 factorial. I grabbed my calculator. On the Casio, you want to go to option and then scroll over to probability, P-R-O-B, and then you can see the X factorial, the permutation and combination are under options. Go over to probability. So what did I just say? So on the Casio, hit the options button, and then go to probability, and then you can find what you want, like what's X factorial or it's NPR. And when you're doing NPR, you would do the N, then you hit NPR, then do R and hit enter. It also has combinations. So permutations, combinations are found there. That was a little side thing. You got it for free. Okay. So that's the answer to, that's part A. Then they say, what happens if there are no restrictions? Well, so I didn't get the right answer at first because I saw, 5 of Alice's friends, so there's 5 people. No, it's Alice and 5 of her friends, so there's 6 people. So of those 10 seats, we need to figure out, well, how many ways can I choose 6 places to sit? It could be that Alice sits here, and then we have B, C, D, E, F, something like that. Like we could have, we don't know where those other people are. We need to choose 6 of the 10, okay? And so then once we pick 6 of the 10, which came in right here. Then we need to figure out, well, we also want to consider that it could be, say we've picked 6 seats, but we have now 6 people that can sit in the first one, and 5 people that can sit in the second one, and 4, anyway, so forth. So that gives us that 6 factorial. So we have to multiply, this is 10 choose 6, and we multiply that by 6 factorial, and that gave us that number right there. Okay, 151,200. Then the next set, they all sit together with no empty seats in between. So what we look at here is that they can take up the first 1, 2, 3, 4, 5, 6 seats. Or they could take up the next 6 seats. Okay, and that's what these little brackets are trying to indicate. It may be less than ideal, but sorry. So you've got 1, 2, 3, 4, 5 different ways that they can get those seats, and then once they pick which 6 seats they're sitting in, then you have to multiply that by 6 factorial as far as how we can arrange them in those 6 seats. So there's 5 sets of seats that we can pick that gets multiplied by 6 factorial, and that's how we get that value right there. Okay, and then the real question was on part B, letter B, part 3. Any 2 of Alice's friends sit on either side of her. Okay, so what I recognized here is that we have Alice, and then there's a friend 1 and a friend 2. Okay, and so Alice could sit 1, 2, 3, 4, 5, 6, 7, 8 spots. She can't sit on the ends because then she wouldn't have somebody on either side of her. So there's 8 spots for Alice. That's where this comes from. And then of her 5 friends, she's got 5 that can sit on one side of her, and then 4 that can sit on the other side. Well, that's all that we know that's absolutely determined for us. So the other thing that we want to consider, say they pick these first 3 seats for Alice and those 2 friends, but then the other 3 people could sit 1, 2, 3, or whatever. They don't have any restrictions. So we have 7 seats now that are not spoken for, and we're going to choose 3 of those. And that's where the people are going to sit. And then we can do 3 factorial to decide how those 3 people arrange themselves in those 3 seats. Oh my goodness. Okay, and so when we do, we end up getting this 33,600. All right, next one. Okay, so on this one it says, how many ways can 12 people be divided into 2 equal groups? Well, so if I have 2 equal groups, that means each one has 6 people. So I have 12 choose 6, or they like to write it this way, 12 choose 6. But that's saying how many ways can I pick group A? Well, okay, I think what the reasoning is I want to pick 6 people, but it could be that those 6 people are in group A or in group B. Okay, so it doesn't have to just, so the book says this, 12 choose 6 divided by 2. I think that's because they could either be in group 1 or group 2, which gave us, what is that, 12 choose 6 gave me 924 divided by 2. I don't know, divided that by 2. I'm too tired to, 462. Is that the answer? I pulled the answers here. Yeah, that was part A. I think it's because those 6 people could be in group A or in group B, but it would work out the same way. So you have to kind of divide that one away. Okay, then the one with 3 equal groups, that's part B. We have 12 people. In order to have 3 equal groups, we want to pick 12 for the first group. So 12 choose 4. And then now we've got 8 people left, but we still need another group. So we've got 8 choose 4. And then you've got 4 people left. 4 choose 4, by the way, is 1. So there's just one way for those last 4 people to get picked. But they went ahead and said, divided by 3 factorial. Why is that? Because if you have, let's call, oh, sorry. Some of these get a little tricky. This group could be, like, we could have, if the first one here was group A and this was B and this was C, then what we have is we have different ways. We could have said A, B, C, or we could have said A, C, B, or we could have said B, C, A, or B, A, C, or we could have said C, A, B, or C, B, A. I think that's the only way we can. So we have 6 choices there we've already set the groups up here, but we need to divide out by 6 so that we're not counting. So it's not just, these different scenarios don't get, they get divided out. Let me see if I can say that better. I'm sorry. We've grouped these people, and if this grouping, but they were picked, we're implying that there's a difference between, say I have person 1, 2, 3, and 4 in the first group, and then the second group is 5, 6, 7, 8. Okay, my notation leaves a little to be desired. And then it's 9, 10, 11, 12. Okay, so we've divided the groups, and that's how they played out. What we're saying is that if this group weren't first, if that group, undo, delete. Okay, sorry. If that group wasn't listed first, but was instead listed third, it would still be the same grouping. Okay, and so we have 6 ways that we could group our groups, but they end up being it ends up being the same when we're just trying to figure out how many ways can we divide the entire group into 3. That was a little tedious, but okay. So 12 choose 4 is equal to. This would be 495 times 8 choose 4 is equal to, I'm using my calculator, but you can't see it, sorry. And then 4 choose 4, we already said was 1, divided by 6. So if I have 495 times 70 divided by 6, that gave me 5775. Is that what they said? 5775. There we go. I hope that was helpful. Keep practicing. Let me know if you have questions. These are tricky. There's just no way around it. And you get better with practice, but they're tricky. So good luck. Let me know if I can help.